So the Hutchinson effect and the work of Ralph Ring and Otis Carr, if controlled, are capable of providing free energy to the world, which according to Mr. Ring is what Nikola Tesla had always envisioned for humanity. I need to find out more about Tesla and the origins of zero-point energy. I'm therefore taking a detour to West Palm Beach, Florida, while Dominique stays behind to do some research and determine our next guest. In Florida, I'll be interviewing a man named Jeff Bahari, the curator of the turn-of-the-century Electrotherapy Museum. He should have more insight into what Tesla was and on his inspiring work.
Hey, Ralph. Welcome to my little Tesla museum.
Hey, great to be here. Thanks so much for letting me in.
Yep.
What an interesting place you've got here. Wow. Look at all this stuff. This is incredible. Now, this looks like it is not very current. I mean, this stuff dates back, what, to the early 1900s?
Most of these machines are 1890s to the early 1900s.
Right.
1920s being about the latest here.
And how would you describe all the stuff? Are these all Tesla coils?
They're all Tesla coils. They're all in adaptations of Tesla's patents in some way, normally made for medical use.
All right. And of course, Tesla is the inventor of the Tesla coil, but what did he originally invent it for?
Originally, he was looking into a new way of generating high voltage. He was looking for a new way of distributing energy. It was part of his early alternating current experiments.
So he was looking for a way to create energy, to process energy, and how to distribute it.
Right.
So you have quite a bit of medical devices here. What else do you have that's along these therapeutic lines that Tesla was working on?
Well, they started off with the X-ray machines, and one of the first things they discovered was that they thought initially X-rays were curing people of a lot of problems. And then afterwards, they found that some of the tubes weren't working properly, and that they attributed maybe the electricity was what was curing some of them in some cases. And it goes back to an initial experiment of someone trying to cure a patient of blindness. And they noticed if you X-rayed someone that was blind, they would see flashes. One of the early patients had remarked that during all of the different treatments with different tubes, her migraines completely went away. And the doctor ended up attributing it to the machine because that was the only constant. All of the tubes he used were different, and so that was kind of the birth of electrotherapy from a Tesla coil point of view. And they went on to develop these surgical machines, and by the 20s, they were the most humane form of surgical tool available because you could cut and cauterize tissue, and especially with cancer, you could remove cysts without reinfecting other parts of the body. You were able to precisely cook and cut as if you had a laser.
So these were actually used to perform surgery on people?
Right.
Using high voltage instead of a scalpel?
Right, exactly. There were tools such as this that could connect to those machines, and you can regulate a spark length and literally plunge into tissue or cut around it, remove what you wanted, and leave what you wanted left alone, left alone.
Sounds like something out of Star Trek.
Yeah, it is.
But how old is that? We're talking, what, over 100 years?
This is 1920. And this had the advantage with Tesla coils. As you were cutting tissue, it would actually seal the blood vessels, so there wouldn't be excessive bleeding involved. So, and many times it meant life and death for someone that was being operated on.
So how is it that Tesla began experimenting with energy in a way in which that no one else before him did?
He found that by resonance, he could obtain voltage regardless of the turn-to-turn ratios in the coils.
And that means, in English?
That means that you could take a small amount of wire and get a lot of voltage.
There you go.
And at the same time, the voltage was relatively safe to handle. And there were other effects they found with it, such as heating of the body and different physiological effects on tissues.
So you have some examples over here of how Tesla technology was used for healing even close to 50 years ago.
Right.
Yeah, these are incredible. These are the violet rays?
Right.
Yeah, show me some of these. These are really wild.
Here's an early example. It was made by the Renew Life company of Chicago.
All right.
And it was basically a handheld Tesla coil.
All right.
You could plug different glass electrodes made for all parts of the body imaginable, and then a few unimaginable.
So there's a little Tesla coil in here.
Right.
All right. And then you would take whatever piece that you wanted, whichever one would fit whatever body that you were trying to heal, and you put it in here.
Exactly.
Okay.
And these would normally light up inside, and,
Yeah.
and the sparks would be transmitted through them, and you could treat your face, or
You could adjust the power there?
you could adjust the intensity, and some of them even come with ozone generators. You could inhale the ozone.
Good Lord.
And
Was that healthy?
to a certain extent, but with these machines, you can knock yourself out if you're not careful.
Yeah. That would do the trick, wouldn't it? And were these popular back then? Or?
There were literally hundreds of thousands of these manufactured.
Good Lord.
So when people say, what are Tesla coils used for, or were they ever commercialized? It's a prime example.
Wow, extraordinary. You've got quite a number of them.
Oh, we've had, I estimate at one point, over 200 machines.
200 different models.
Yeah, right.
Okay, so these are all the different types of models that were put out.
These are a few examples.
So Jeff, you have some working models of Tesla coils. Can you show me what they look like when you fire them up?
Right. This is one of the best examples we have. It was made by a company called Fisher.
Right.
And it was actually a portable X-ray machine. You could just attach a tube to here.
Yeah, let's fire this thing up. See what she'll do.
Believe it or not, this is what an average Tesla coil would have looked like, built by Tesla. You can see a kind of...
So how many volts was that?
That's around 250,000 volts.
250,000. So you have a lot of different Tesla coils here, and they all do their own thing, don't they?
Right.
Well, show me a few more, because I'm anxious to see other Tesla coils doing different things.
Sure.
Okay. Wow, what's that?
That's an ozone generator that uses Tesla technologies.
So does this thing still work? Is this something that you've made, or?
Yeah, I've made this one here. It can still be fired up. You don't see much of a spark from it, but
We'll get some ozone, though, won't we?
in the dark,
Yeah.
if you attach some wires to it, you can actually light up a room by, this is actually the electric effluves produced by this machine in the dark. So you can actually use it as a light source.
Probably not the most efficient light bulb ever, but it would work.
Right.
At 50,000 volts. All right, yeah, let's turn it on. See what it'll look like there. I can really smell the ozone.
It infiltrates the room quickly. You can't see much of a spark from it, but in the complete darkness, the whole of the air turns violet.
So how did you get started investing all your time and energy into this?
Well, I was always a pack rat, and when I was still in school, I was at a flea market and found this machine and had no idea what it was. Brought it home. I plugged it in, it started making noise and humming, and the TV started flashing across the room. And I thought, I better unplug the TV before I damage something.
So rather than plug this strange device, you figured I'd better unplug the TV.
Right. And when I got to the TV, I found someone had already unplugged it. So the TV was making sounds and the tube was flashing a bit. And to me, it was something like outer space. And I had to learn more.
So the TV wasn't even on.
Right, the TV wasn't even plugged in.
So you have a few others here. It looks like they do similar things. What does this one do here?
This in particular was a coil that they found in the early days of radio. Of course, Tesla's now credited with the invention of radio over Marconi, but they found that the Tesla coils could be used as a power supply for wireless telegraphy. And Tesla had bigger dreams than this as far as transmitting electrical energy without wires. But the first practical results were radio signals.
Really?
And this is a reproduction I built of such a machine.
Wow. Well, how many volts is that?
That's about 150,000 volts.
So this would have been used for a power supply for a radio?
Right. Actually, a radio transmitter.
So do Tesla coils actually give off radio frequencies as well?
Correct. They generate a wide range of radio frequencies.
I mean, there's so much different types of electricity. I mean, there's static electricity, you know, there's
Right.
electromagnetic. Do you have any things that demonstrate the different types of electricity?
Well, there's a small machine here. This is actually one that was built to simulate static electricity. We don't have a proper platform here, but it would actually make your hair stand on end, similar to a Van de Graaff machine.
Really?
But with much more powerful. and it consumes about 100 watts of electricity.
It's more than my stereo.
Over 100,000 volts out of it. This type of machine, the output can be regulated to produce almost DC, where you could charge Leyden jars or do experiments like Ben Franklin was doing 100 years earlier, only a much more simplified method.
So we know electricity can make things spin and turn and flip. How about levitate? Is there any connection between these high voltages and making objects actually lift off the ground?
There are eddy current effects that you can use with Tesla-type circuits, where you can have a large electromagnet with an iron core and place something like an aluminum ring on top. And the ring will act like a short circuit of a wire of a transformer, and you can actually send these rings into the ceiling if by accident. I mean, steel, you can use an electromagnet and pull materials out, but if you have brass and aluminum mixed together, it's harder. These high-frequency currents can actually cause them to lift up, and where you could separate them in a way for recycling materials or reclaiming materials.
So Jeffrey, what's this? It looks like something we saw in the other office there.
This is a prototype I built specifically as a new modern use for a Tesla coil.
Really?
And it's basically, there's a craze today to find a portable X-ray machine that's practical. And they're actually going back to the early Tesla technologies with the high-frequency coils. And the problem is, because the technology is so far removed, they're using modern electronics to try to do it, and they end up with these machines that are 100 pounds and that don't work that great compared to the traditional styles. So here's an example of an actual, built with modern materials, but using turn-of-the-century methods, a portable X-ray machine, or a power supply for an X-ray tube.
Wow, let's take a look. So what you're saying is that there is a need for having portable X-ray equipment to take into combat, say?
Right. Yeah. One of the things interesting, the tsunami, there were so many victims. How are they going to identify the victims on location? And you can use dental records. And the problem was, how do you get X-ray machines into
the field,
into rubble,
yeah,
more or less.
Right. And you can run this off of a series of batteries.
Right. Right. You could, if you wanted, you could run it off of a computer battery backup, even a small one.
Now, of course, if this was part of an X-ray machine, it wouldn't be a big spark that way, but you would use that energy to drive the X-ray tube.
Right. You would have a regular X-ray tube head connected instead of those spark terminals.
Right. This is absolutely extraordinary. The stuff you have here is, in some way, very old technology, but in other ways, it's still cutting edge.
Right. And as technology changed, a lot of these machines, they kind of gotten forgotten. There's many new fields, as Tesla had envisioned initially, that could still be explored.
Yeah, for therapy, for communication, for transmitting electricity through the air.
Right.
Wasn't there a report that just came out that talked about MIT scientists using this kind of technology?
Right. Someone was lighting a bulb from a few feet away, and it's something that Tesla was doing a few hundred feet away.
Just sending electricity through the air?
Through the air and through ground waves also.
So there's really no limit to where this technology can take us in the future, is there?
I think when we go back to the beginning, it's endless what we can do.
Yeah. Jeff, what an adventure. Thanks so much for showing me this stuff today.
Oh, thanks for stopping by.
I gotta run now, but let's talk again.
Okay, anytime.
Appreciate it. Thanks so much.